Hi, I'm Valley from Greenwood Bananas. This week's presentation is on off-grid systems part 2. So after watching the presentation, you'll understand the importance of the interval data, being in this case the load audit filled out by the customer, the importance of the generator-battery relationship, and what are some of the other design factors involved. We'll be talking all the way up to the generator side of things. If you like what you see, hit that subscription button. Let's get stuck into it. Ready, steady, go! So where we left off was effectively the customer has accepted the preliminary costing, so now it's time for the formal proposal. So we have to get into the nitty-gritty of the design. We have to look carefully at all factors, and this is when we get the customer to fill out a load audit table in detail. So a load audit is incredibly important, and effectively it's a list of what appliances you have, what their wattage rating is, how long they're on for, and also when they're on. Because when they're on determines the capacity of the inverter charger. The load audit should be signed by the customer and they should fully understand, and that's what you're designing your system on. Let's assume that the customer's actual daily load will be around 12 kilowatt hours compared to the stated 10 kilowatt hours. And from analysis, it is highly likely that most of the daily loads will be outside of solar production hours. In fact, the split is 60% night and 40% day. This means that 12 kilowatt hours times 0.6 equals 7.2 kilowatt hours outside solar production hours. So this energy must come directly from the battery, and possibly the generator will contribute as well. The remaining 4.8 kilowatt hours comes from the solar component, but that's if the sun's out. What about 4, 5, 6, even 7 days of cloudy weather where the amount of solar contribution is significantly less? What happens then? Well, one or two things. You've sized the battery system accordingly and for X amount of days of autonomy, and/or you have more generator contribution, which can be a good thing or a bad thing depending on your customer's perspective. Maybe the customer said, I only want the generator to run during winter months. And if this is the case, you must have to take this into account with the battery storage capacity design. But remember, batteries do not produce energy. They only convert energy that has been inputted into them. With off-grid systems and anything that involves battery storage and a renewable energy component and a fossil fuel component being a generator, it really is a balancing act. You're altering one thing, you're affecting the contribution of the other two inputs. If you start talking about wind as well, then it even complicates it even more. Altering the main components has cost ramifications. Batteries and generators are still quite expensive. Solar is fairly cheap and there's still financial incentives available, but not for batteries and generators. But in this case, the roof size physically limits the amount of solar we can factor in, and all things are related. Our roof in this case can comfortably hold 40 by 350 watt panels, 14 kilowatts. 14 kilowatts will produce on average in Melbourne, north facing, around 50 kilowatt hours a day. More in summer, less in winter. So in this case, the roof is not really the limiting factor as compared to the average daily load. We know that there will be a genset in the picture, in other words a generator, but what size? Also, are we going to design a system that is AC and DC coupled, or AC or DC coupled? We will design an AC coupled system. We will select our inverter charger based on the load audit results. We'll select a lithium iron phosphate solution for the energy storage component. In this case, the customer has decided to go down the AC coupled. For Plan B type of designs where the customer's budget is fairly high, you'd ideally go for an AC and a DC coupled combined system to cover all bases. In our preliminary costing, we offered a 5 kilowatt inverter charger, but after further load analysis, we will go with a 7 kilowatt model. and this was due to the reverse cycle air conditioning being used in winter. Now originally a wood heater was going to be used as a primary heat source, but this decision was changed at the last minute. This is a classic example of what can happen. Now an incredibly important question is, but what about the future? Now a good designer will ask those questions. They'll ask, well, you've got young kids, they're going to get older, they're going to increase their consumption, or you're living in a house, you may have more adults coming to live in your house. So are you going to design for growth? So we have selected a 7 kilowatt continuous inverter charger. Next is the AC grid connect inverters. We're looking at 8 kilowatts of solar, capable on average of producing 28 kilowatt hours a day, more in summer, less in winter. So I have selected an 8 kilowatt single phase grid connect inverter. With the batteries, we are looking at 2 days of autonomy. So that's 24 kilowatt hours available. Using lithium, we can discharge 80% of the entire capacity of battery at an adequate C rating. This means that total battery capacity is 24 kilowatt hours divided 0.8 equals approximately 30 kilowatt hours. Battery voltage is 48 volts, so individual cells are 625 amp hour. Next cell size up from 600 to 700 amp hours, so it's 700 amp hours at 48 volts. We've selected the battery system as 700 amp hours at 48 volts, but the max size of the batteries in question are 350 amp hour at 12 volt. So we have to series and parallel the batteries. We'll need 4x batteries in series, that gives 350 amp hours at 48 volts. Then we parallel another bank, a total of 8 cells in total, 700 amp hours at 48 volt. With the energy storage component, you're looking at lead-based solutions, tried and tested. Lead-based batteries have been around for a very long time, compared to these lithium solutions that haven't been around that long, and there's some pretty interesting claims on how long they're actually going to last. So it's a hard one. You have to weigh up the pros and cons and do a cost-benefit analysis. With lithium, we have a 700 amp hour battery at 48 volts. We can take 80% out of that and still get 3,000 cycles plus, and if required, discharge at C1. So we can service large, short-term loads if required without reduced lifespan of the battery. At the end of the day, you have to weigh the pros and cons of what energy storage chemistry system you select. Tried and true lead-based technologies versus relatively new lithium solutions. Could also look at flow batteries, hydrogen fuel cells, etc. Also may have to factor in cost of replacement as well. In most cases, when designing an off-grid system, a generator is required due to large loads for sustained periods may be better off serviced by a generator. During cloudy conditions, batteries may be put under undue strain, hence generator input. If there's limited solar due to space constraints, the generator shares the workload. Thanks so much for watching our presentation on off-grid systems part 2. Looking forward to part 3. I'm Veli from Greenwood Solutions. If you have any questions, any inquiries, any answers, feel free to drop us a line. If you like what you see, hit that subscription button. See you in part 3. Bye.